Bienvenidos, or welcome to our final day of graphing rational functions. Today is going to be all about describing what our function is doing at different points along our graph. I'd like to start with something that we're familiar with. So that's why I've drawn off to my side a little coordinate grid and a linear function. Now, if you don't want to, you don't have to copy this down onto your paper. This is just to get us introduced into the topic. How would you describe the domain and range of this function? Now you may have said, well, the domain is all real numbers, and the same thing for the range. But I'd like us to write this as negative infinity to realize that our function is able to approach positive infinity in both the y direction, since we're going to continue going up, and in the x direction, since we're going to continue slowly moving more to the right. Same thing going in the opposite direction. We can go into negative infinity with both x and y as we continue on, okay? So that's the point I wanted to make there. Now you'll notice as we look to our very first thing, we have some interesting notation here. If you're not familiar with that arrow to the side, that arrow can be interpreted as approaches. I'm going to make that note here. That is equal to approaches. So reading out our problem now, it says, as x approaches 3, but we have a weird little symbol here. It's a plus sign, where we would normally see an exponent. Now what this means is we can go over to a value, but at x equals 3 we have a vertical asymptote. So our function doesn't exist at that point, but we can consider what's going on with our function when we are approaching it from the right hand side and we're approaching it from the left hand side. So which one goes with which? Well, when you are looking at a coordinate system, what do you associate with positive numbers? The right-hand side or the left-hand side? Yep, the right-hand side. That's where all of our positive numbers. So that's how we interpret the plus sign. So plus sign means from the right. And if you ever get confused, just think about that coordinate grid that we just talked about. What do you think that minus sign in the exponent means then? That's right, from the left. So this is what allows us to consider what the graph is doing around the point x equals 3, even when our function does not exist there because there's a vertical asymptote. So now going back, we can read this as x approaches 3 from the right. F of x, or our y values, are going to approach what? Well, you just come over to your graph, and we know that we're coming from the right of x equals 3. Pick any point on your graph and follow it along with your pencil. Follow it, follow it, follow it. Where is it going? If you guessed positive infinity, you are absolutely right. Connecting it back to this. This is going to continue going up into infinity for our range, and that's what this one's going to do. It's going to go up, 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 all the way approaching positive infinity. Let's look at the next one. As x approaches 3, this minus sign says from the left, so we're on this side of the x equals 3. What is our f of x doing? F of x is approaching negative infinity because we're going smaller and smaller and smaller. That's what our y values are doing. Here we're looking as x approaches positive infinity. Let's go to our graph and see what that looks like. Okay, so now we're considering as x gets bigger and bigger and bigger. Well, when we see notation like this where x is going to either positive infinity or negative infinity, this is our indicator that we're talking about end behavior. Does that sound familiar? It should from our radii foldable. Remember what end behavior was? We weren't interested in what was going on the far right when we were looking at positive infinity and our far left. that corresponds with negative infinity. Why? Because as we keep on moving along our graph this way, x's will continue on until we are approaching infinity, and the same on this side except negative infinity. So that's why I'm going over here to my far right when it says x approaches infinity, and I'm seeing what my y values are doing. Now, since I have this horizontal asymptote, I know that my graph is going to approach this line but never quite touch it at the end, since that's where we are not allowed to cross the horizontal asymptote. Our horizontal asymptote, they tell us here, is at y equals 0, so my y is going to approach 0. What do you think it's going to be as x approaches negative infinity? Yep, my graph is going to be doing the same thing. Even though it's from the other side, we're still approaching 0. All right, now, right now, take a look at number 2. See if you can fill it out on your own. Double check it with the video. You can fast forward a little and double check your answers. If you had some questions and didn't get all of them, then rewind it back. If not, we're going to go through it right now. All right. As x approaches -3 from the positive side or from the right, so I go to my -3, I'm looking from the right, put my pencil on my graph, follow it along, approaching that line. What is f of x doing? It's approaching positive infinity. As x approaches -3 from our left-hand side, from the negative side, I'm going to go to the left-hand side of that point, x equals -3, follow my graph, and I'm going down to negative infinity. As x approaches 5 from the right-hand side, so I go to my right-hand side of that, follow my graph, and f of x is going to negative infinity. As x approaches 5 from the negative side, so from the left, so I go to the left-hand side of x equals 5, follow my graph, and f of x is approaching positive infinity. Then I look at my end behavior because I see that I'm now approaching not just some number, but infinity and negative infinity. So positive infinity I know is my far right. I follow my function, and looks like here my horizontal asymptote is at y equals -1, and that's what I'm going to be approaching. And as x equals negative infinity, we're going to be doing that same thing and approaching f of x equals -1. All right, not so bad, huh? Let's look at number 3. The last thing we're going to talk about today is being able to come up with the equation of a graph when you're given its characteristics. Now, the cool thing about this is that we don't have to learn anything new. We already know enough to be able to interpret this and write our own graph. We'll just take it step by step. So we have a hole at x equals 1. Think back to our notes about holes yesterday. What was special about it? Well, we had to find factors that were both on the top and bottom that we could cancel. So we know that we're going to end up having some sort of factor that's both on the top and the bottom. How do we figure out that factor? Well, we have what x equals, but with the factor we need it to equal to 0 when we plug in x. Our factor in this case is going to be x minus 1. Do you see why? Right, x minus 1, when we set that equal to 0, we arrive at x equals 1. Another way you can think about it is, if I plug 1 in here, am I going to get 0? Yes, I am. All right, but since we're working with the whole, and we're going to need to be able to cancel it, we need it on the top and the bottom. X minus 1. All right, that's all of the information that we can gather from this point, so we go on to the next thing. We have a vertical asymptote at x equals -4 and x equals 3. Vertical asymptotes were associated with the a in radii. And what did we do in that point? Well, we looked at our denominator and set it equal to 0. So we have a similar situation as to how we found the factor for the wholes. We need to find factors that when we plug these in, they're going to give us zeros in the denominator. If you haven't noticed already, a neat little trick is that it's just going to be the opposite sign of whatever number we have here. So our factor in the denominator is going to be x plus 4 and x minus 3. Do you agree? Yep, these in the denominator could give us vertical asymptotes. And do we need anything up in the numerator? No, be really careful. If we had these factors in the numerator as well, there would be wholes and not vertical asymptotes, since we would be able to cancel them. All right, going on to our next step, x-intercept. Remember, that relates to the r in radii, or roots, and that meant that we would set our numerator equal to 0. So if x equals 0 in the numerator, then we're going to need just an x up in our numerator, because, right, that corresponds to setting x equal to 0 for our x-intercept. Finally, we look over at horizontal asymptote at y equals 0. Remember, horizontal asymptote corresponds with our e in radii, our end behavior. With end behavior, we're looking at the degrees of our top and the bottom. We have 3 possibilities. We could have bigger on bottom, and that's our bobo, or y equals 0 for our horizontal asymptote. We could have bigger on top, which then indicates that there's no horizontal asymptote. And we also have stab. If it's the same, then we look at y equals a over b, where a and b are our leading coefficients of the top and bottom respectively. All right, so we have y equals 0, so it corresponds with bigger on bottom, or bobo. And let's check, what degree do we have on top? Well, we have an x times an x minus 1. When we distribute this out, our highest degree is going to be associated with x squared, that 2 there. And when we look at the bottom, we have 3 factors, and they're each of degree 1. So that when we distribute these out, so for example, if I take a look at these 2 first, the highest degree is going to come from when I multiply x and x, so that's going to give me x squared. But then I still have another factor. So since this has the highest degree of 1, when I multiply what's now going to be my quadratic with this one, my highest degree is going to be x cubed. Now, I didn't have to do all of that work because I just noticed and worked with my highest degrees. If you're still struggling to see that, go ahead and go through the distribution. It won't take you very long. Once you have it all distributed out, you'll be able to pick out the highest degree a little more easily. All right, so I have a higher degree on the bottom, and so it fits my description. This doesn't tell us any new information since we're already in that situation. That's our answer. We'll be getting more practice with this in class, but that's it for today's video. Enjoy your night, and I'll see you tomorrow.